All right, good morning, everyone, and welcome back to Math 115. So today, we're going to keep going with some more of this trig stuff. But before that, let me just remind you of what's going on with our class. So there's a homework that is due tonight. I'm extending it to be due tomorrow night instead of tonight. So you can have a little more time to work on that. I already...
You don't have to go over it today then, because I'll just come to office hours tomorrow.
Okay.
If it's due tomorrow night.
Well, we'll do one example anyways. Okay, so that's the homework. I'm gonna post homework 4.3 soon. Your next assessment, and this is really important, everyone, so please make note. Quiz 6 was scheduled to be taken on November 8th, but I forgot that's election day, so we're not gonna have class that day. Instead, we will have the quiz the day after, on Wednesday, November 9th. Okay, so last 15 minutes of class on Wednesday, November 9th. That'll be quiz 6. I'll talk about the content for quiz 6 soon, but that's far enough away that I'm gonna put that off for a minute. Okay, so this week office hours are gonna be back to normal, although I've been kind of thinking that maybe I should switch one of them. Because there are some students who can't go to my afternoon office hours. So I was thinking what I might do is something like, we'll have one in the morning, maybe on Tuesday?
No, Thursday.
On Thursday? Which one do we want to keep?
Keep the Tuesday one.
Does it make a big difference?
Yeah, because I can't go to the Thursday one.
I'm done with lab now, so I'm kind of...
Okay, so is there anybody that doesn't? Okay, who wants to get rid of Tuesday? Who wants to get rid of Thursday? More people for Thursday. So probably what we're gonna do is we'll get rid of Thursday. Okay, maybe we won't do that. I don't know. I'm gonna have to send out like a form or something like that. Like a Google form to collect, yeah, exactly. Something like that. So, because I want to reach as many students as I possibly can, and I realize, like, if you just have a class Tuesday, Thursday at this time, you're just kind of hosed for office hours. So what I want to do is maybe incorporate something like Wednesday after class, like 9:30 to 11. Something like that, so that I can reach more of you. But I'll send out a thing about that, and we'll discuss more later. For now, I'm definitely having office hours tomorrow from 2:30. Actually, I'm going to be there from 2:15 to 4 o'clock. So lots of quiz makeups during that session, so just come to my office. We'll get you set up with a desk. I am really kind of behind right now on everything. I've just been like redlining it, and my mental health is in the proverbial gutter. So I know there's a lot of emails out there that I have yet to answer. I promise I'm trying. I'm going to get to them. I'm going to send you correspondence back, especially some of you who are trying to talk to me about the drop deadline. I know that's Wednesday, so I'll make sure to get back to all of you before then. I'm trying. But okay, that's all I have administrative-wise. Are there any administrative questions before we start in on content for today? Okay, doesn't seem like there are. I do want to talk really quickly about a problem or two maybe from the homework, because it sounds like the homework is a little bit tricky. Have you all been feeling that way as well? Well, let's look at the problems. So, yeah. Let's try something like this one. Okay, so what do we have? We have cosine of pi over 4. Let me write it down. cosine of pi over 4 minus sine of pi over 6. So let's start with this one. Okay, so we're going to use the same process that we have been using, which, let me copy this thing so that we have a unit circle. Copied, that'll be useful. Okay, so how do we go about doing this? Well, the cosine is a function, okay, sine is a function, and the inputs of these functions are angles, or if you want, you can think of them as arc lengths, okay? So pi over 6, that's just a number, right? It's like 3.14 divided by 6. If you said that this was like 1 meter, okay, then pi over 6 meters would be like a little more than half a meter. You'd put it here, right? Okay, that's what it would look like. So you can think about it as an angle, which we're going to inscribe inside of the unit circle, or you can think about it as an arc length on the unit circle, because when we measure angles using radians, the arc length is actually the same number as the angle which we put inside. Okay, so they're the same. So how do we do something like this? Well, we're just going to inscribe the relevant angles, which, let me put another unit circle here. So let's first do pi over 4. So what kind of angle is pi over 4? Well, I know pi over 2 would be a 90-degree angle. So pi over 4 is half that much. So it should be what kind of angle in degrees? 45-degree angle. Okay, so it looks like so. Maybe I'll use a different color. So this is our angle. We put one side on the positive x-axis, and we measure however many degrees or radians in the counterclockwise direction. So this angle here is pi over 4. And what is my goal? My goal is to use pi over 4 as the input in the cosine function. Can someone give me like a one-sentence description of what will be the output of the cosine function for a given input angle? In other words, what does the cosine function do? It's equal to x. Could we be just a tad bit more specific? The x-coordinate of what? Of a point on the unit circle, right? Which point? Yeah?
The radius.
Yeah, we're going to point in the direction that the angle tells me to point in. If I turn myself, so imagine this is like a bird's eye view, and here's the top of my head, okay? I'm going to turn and point in the direction of pi over 4, and I'm going to say, that point right over there. I see it. Okay, this one. That point lives in the coordinate plane, right? It's a point on the circle, yes, but it's also just a point in the coordinate plane, right? It has coordinates. It has coordinates x and y, where x is how far away we are from the x-axis, the x-coordinate is this distance shown in red here, which is how far away we are from the y-axis. And then the y-coordinate, of course, is going to be this length here, which is how far away our point is from the x-axis. Okay, so it's just a point living in space, and the cosine function's job is, I give the cosine function the angle, the cosine function gives back to me the x value of the point on the unit circle, which is corresponding to this angle. So we put the angle inside, we shoot out a ray at this point, and then we say, well, what is the x value of that point? That is what we are after. So how might I determine what this horizontal distance is? Because that would be the x-coordinate. How am I going to figure out what that is? Yeah?
You know, hypothesis is 1, and then it's a 45-degree angle. It's a 45, 45.
Exactly. So we are going to draw a triangle. And we have information which we know about that triangle, right? How do I draw the triangle? What sort of line segment am I supposed to draw in order to finish the triangle? A vertical line segment, okay? So that would go here. And this is a 90-degree angle. This is a 45-degree angle. So what angle is here? Also 45, or pi over 4, however you want to say it. Okay, so like Gavin said, I know one more critical piece of information about this triangle, and that is I know the length of one of the sides. The side length which I know is this one, the hypotenuse. I know that this length has to be 1 because this is a radius of the circle. It goes from the center of the circle to the outside of the circle. And this is the unit circle whose radius is always 1. So this length here must be 1. So my goal is now to determine what is this length. Well, it's a 45, 45, 90 triangle. What should I do to the hypotenuse length in order to get the short leg length in a 45, 45, 90 triangle? Good. Divide by the square root of 2. So this is 1 over the square root of 2, or if you want, you can rationalize square root 2 over 2. Okay, so that's what this one is. So this guy is square root 2 over 2. All right, so are there any questions on how we did that one before we do the sign? Okay, so yeah, like we said, we put the angle inside. That angle points at a point. And that point has coordinates. And the x-coordinate is the output of the cosine function when the input is the angle which points at that point, whose x-coordinate is that x-coordinate. Okay? So, okay. So now let's do the second part. We're supposed to take this number, which is square root 2 over 2, and subtract another number, which is going to be the output of the sine function. Now, what is the sine function's job? It gives you the y value of the point, which is pointed at by the angle, which is the input, which this angle input is pi over 6. So I'm going to draw it inside. Well, pi over 6 is less than pi over 4, which is 45 degrees. How many degrees do you think pi over 6 is? It's 30 degrees. You can figure it out. How can I figure out what that angle would be in degrees? Multiply by what? 180 over pi. If I do that, what do I get? I cancel the pi's. 180 can be divided by 6. We get 30 degrees. Okay, so that's how you can convert. So here we're going to put an angle. This would be 45. I need to do less than that. It needs to look something like this. Okay, and this is the angle, which is 30. And this point has an x-coordinate and a y-coordinate. My goal is to find out what is the y-coordinate, because that is going to be what is returned by the sine function. The sine function has a job to do. The sine function says, you give me an angle, I will give you the y value of the point on the unit circle which that angle points towards. So we draw in another triangle with a line segment which should be a vertical line segment. Then this is a 90-degree angle. This is a 30-degree angle. What must the last one be? 60, because all the angles inside of a triangle must add up to 180 degrees. Okay, so here we have a triangle. And I know one of the side lengths. It's this side length. It has to be 1, okay, because it goes from the center to the outside of the unit circle. This side length is going to be less than 1. You can tell that it's less than 1 because 1 would be going all the way to the outside of the circle, and this doesn't go quite that far. It just goes to here, okay? So it's going to be less than that. How much less than that is going to be determined by, well, how do I go from one side of a 30, 60, 90 triangle to the other? Well, you can go from the long leg to the shortest leg by doing what? dividing by 2, because to go from the short leg to the long leg, we would multiply by 2, right? So the ratio is that this side length should be half as long as this one is, right? Should be half as long as this one is, because this one is double the length of the short leg, right? So they have this ratio relationship. So we know that this length here, which, by the way, is the y-coordinate of this point, is 1/2. Okay, and what's this length going to be? Let's just do it for fun.
Square root of 3 over 2.
Exactly, it's going to be square root of 3 over 2. Okay? So what do we get? This is going to be square root 2 over 2. That's what we get when we do cosine of pi over 4. Then I have a minus sign, and now I need to write what is sine of pi over 6. Sine of pi over 6 is the y-coordinate of the point, which is pointed at by the angle pi over 6. And that y value is 1/2. So I'm going to subtract 1/2. So if I simplify, these two fractions have the same denominator. I can just subtract the numerators. So I get square root 2 minus 1 all over 2. That would be my final answer. Okay, so that pretty much shows us how do we figure out sine and cosine. The only thing about this is that, well, this time the angles were all in the first quadrant, which makes it kind of easy, right? But what would happen if the angle was down here? We have to be a little bit careful, okay? We have to be a little bit careful because the x-coordinate of this point is going to be what? Negative, okay? It's going to be negative. And also the y value is going to be negative, right? We have to be a little careful about that. We can also incorporate negative angles, okay? How do I do a negative angle? Well, instead of measuring the angle in the counterclockwise direction, I'm going to measure the angle in the counterclockwise direction. That's how I'd handle a negative angle. And how would I handle an angle which is bigger than 360 or bigger than 2 pi? What would I do then? Yeah, you would subtract 2 pi iteratively until you get something which is coterminal, right? So if I go like, around 3 times and then end here, that's the same for the sine. As far as sine and cosine are concerned, doing this is the same as just going 45 degrees, okay? So this is like going 360 plus 360 plus 45 degrees, okay? So that would be a coterminal angle. We just subtract 360 from it, subtract 360 from it, and then we'd have just our 45. Okay, how are we feeling about this example? Are we confident we could take on the homework, do problems like that? Was there anything else in there that was
I have no clue.
not sure? Okay, well, let me pull it up.
Covered a lot of bases.
Let's take a look at some other ones here. So what would we do for this one? 55 pi over 4. That's too big. We're going to subtract 2 pi until we get something which is more reasonable, right? Can we do this problem? Yeah, sure, we can do this problem. Okay, so let's do this problem. I really don't mind taking a little bit of class time to do this stuff because this is going to be sort of the basis of, and why don't we do tangent, because that's more exciting. Okay, so yeah, I don't mind taking some class time to go over this because this is going to be basically the foundation of what we do for the rest of the class. So let's have another unit circle. Okay, what the hell is that? 55 pi over 4. That's like I'm going to go around like a bunch of times and then I'm going to end somewhere. And all that matters is where do I eventually end up, right? And I know that, okay, I know that this angle is coterminal to 55 pi over 4 minus 2 pi times n, where n is any integer, okay? So like ... -2, -1, 0, 1, ... okay? So I can subtract any multiple of 2 pi. Why? Because a multiple of 2 pi is all the way around the circle. So let me show you here's what an angle would be like. This would be the angle, what? This would be like 8 pi over 4 plus pi over 4. This would be like 9 pi over 4, right? This would be the angle 9 pi over 4. It would point up here at this point. But I could subtract 2 pi from it. What would I get if I did that? Well, subtracting 2 pi means subtracting 8 pi over 4, right? This is the same as 8 pi over 4. So I'm going to subtract 2 pi, and then what would I get? I would get pi over 4, which is just this angle, okay? Which happens to point at the same point as does the angle 9 pi over 4, because these angles are coterminal, okay? These angles are coterminal. So pi over 4 is what I would call my reference angle. It's the angle which is between 0 and 2 pi, which is coterminal to my angle. Okay, so this is basically what we're gonna do here. So what I want is to pick the right number n. I want to pick wisely so that the result of this subtraction should give me, so that the result is between 0 and 2 pi. That's what I want in the end. Okay, so what do? I take 55 pi, and I'm going to subtract a multiple of 8 pi over 4. And I want to do a multiple of 8 pi over 4 such that the result of this subtraction would give me something which is less than 8 pi over 4. Okay? So let's think about it. I can think like, well, should I do 55 pi minus 8 pi over 4, or should I do 55 pi over 4 minus 16 pi over 4? No, that's still not going to get me what I want. What do I want to do? I want to do probably like 55 pi minus, what would be the correct multiple? Well, I want this number to be something like 48 pi over 4. I think is the one we want, right? Why 48 pi over 4? That seems kind of random. Well, it's the multiple of 8, because 48 is 6 times 8, right? So it's the multiple of 8 pi over 4, which is going to cause the result of this subtraction to be what? It would cause the result to be 7 pi over 4, which is between 0 and 2 pi, right? So you can do whatever you want. If you want to go around the circle 6 times, okay, and then end up here, pointing in this direction, you can do that if you want. Or you can just go straight there, like so, okay? So 7 pi over 4 is almost 2 pi, okay? Because 4 pi over 4 would be this angle, right? 8 pi over 4 would be going all the way around. So 7 pi over 4 is 45 degrees less than all the way around. So it looks like shown. So this is the angle 7 pi over 4. And it is coterminal. It is coterminal to the angle which we are supposed to do. So, namely, they both point at the same point on the unit circle. Is that making sense? Okay, so if I want to do tangent of this angle, it's the same as doing tangent of this angle. Let me add a page. So, doing tangent of 55 pi over 4 is going to be equal to doing tangent of 7 pi over 4, which the reason is these two angles are coterminal. They point at the same point on the unit circle. Okay, so what is that going to be equal to? Well, now what do I do with tangent? It's going to have something to do with the coordinates of this point, right? So let's figure out what the coordinates of this point are. Well, this angle here is 45, so I could draw a triangle like shown. This would be a 90. This angle here is 45, This angle here is 45. So what are the coordinates of this point going to be? Well, this length here is 1, so this length here would be the square root of 2 over 2, and this length here would be the square root of 2 over 2, so the coordinates of this point must be square root of 2 over 2, comma, square root 2 over 2, right? Yeah, we have to be careful. Only the x value is positive here. The x value goes to the right, so it should be positive, but the y value should be negative, because even though this length is square root 2 over 2, we're talking about the coordinates of this point, which we have to keep in mind. Are we going down or are we going up? So this one's going to be negative. So, and what do I do now that I have that point? I'm supposed to do tangent. What is the tangent function's job? I give it an angle, and what is tangent supposed to do for me? It should give me back what? The y value of the point on the unit circle, which is pointed at by this angle, divided by the x value of that point. So we take negative square root 2 over 2, and we divide it by square root 2 over 2. And what is the result of that division? Negative 1. Okay, so that's a trickier one. Right? What did we have to do? We had to use the theory of coterminal angles. Okay, we had to understand, well, this initially is not a very friendly angle, right? It's hard for me to imagine what it is like if I go around however many times. But this angle is more like, okay, that I get. That's like almost all the way around. So I just subtract multiples of 2 pi until I get what I want. So if you want, you can just do minus 8 pi over 4, minus 8 pi over 4, minus 8 pi over 4, and just keep repeating that process. But it's probably easier if you can have a little bit of foresight to say, well, I know that the multiple of 8 pi over 4, which I should subtract in order to make the numerator less than 8 pi, would be to subtract 48 pi over 4. Does that make sense? Any questions on how we got the angle to be more friendly? Okay, how about the other part? The other part is confusing too. What are we supposed to do? We put the angle inside, and then we draw this line, which goes to the outside of the circle, right? And I know the length of that line segment is 1 because it's inside the unit circle, right? It goes from the inside of the unit circle to the outside of the unit circle. And then I have to imagine, well, what are the coordinates of the point which is pointed at by this angle? Okay, so we put the angle inside. That angle must point at a point on the unit circle. Why? Because the unit circle has us surrounded. If I'm inside the unit circle and I'm facing in a direction, I have to be facing at a point on the unit circle. Okay, so that point has coordinates, and our job is to find them. We find them using special right triangles. So in this case, it's a 45, 45, 90 triangle, but it could be a 30, 60, 90 triangle, or it could not be a triangle at all. When am I not even going to have a triangle inside? Yeah, if my angle is something like this, okay, then what? Then my triangle, okay, you imagine drawing triangles like this. You draw this triangle, and then this triangle, and then you draw this triangle, and the triangle is basically squishing itself and squishing itself until it basically collapses on itself, right? And then what's going to happen? If we keep going around, then the triangle will look like this, yes? Okay, so you can imagine this thing going around, right? And there's going to be times where the triangle collapses on itself, namely if our angle points in one of the 4 cardinal directions, okay? One of the 4 cardinal directions, then we're not going to have a triangle at all. We're going to have a line segment, which is just a radius. So we'll know the coordinates of those points, obviously, because this point is the point 0, 1, right? This point is the point 1, 0. This point is the point negative 1, 0, and this is the point 0, negative 1. Okay, so that's what we would do in that case. So our goal is to find the coordinates of the point which is pointed at, If it's a triangle, we can figure it out using special right triangles. If it's a line segment, well, it's easy to find out what the coordinates of the points are if we just go straight up or straight to the side. All right. One point of confusion, I think, is this part here where, well, we find the lengths of these sides, and we're very tempted to just say, well, those are the numbers which should go here and here, right? We're tempted to say that. But we need to be a little bit careful because even though this is, when we use square root 2 over 2 to describe the length of this side of the triangle, length is always positive, but the coordinate is in the fourth quadrant, so we know the y value should be negative. So that's how we made this negative instead of just plugging in that number. All right, any questions on this example? Yes?
I just want to make sure, why did you use 8 pi over 4 again?
Because 8 pi over 4, so what I want to do is subtract 2 pi. But in order to do the subtraction, I need to get a common denominator, right? So to get a common denominator between 2 pi and 55 pi over 4, what do I do to 2 pi? I multiply by 4 on the top and on the bottom. And that gets it to have a common denominator. So that's why I'm subtracting multiples of 8 pi over 4, because 8 pi over 4 is nothing but 2 pi, if you simplified it. But it's just in a friendly form, because if I do it like this, I just have to subtract the numerators from each other, right? Okay. Good question. Any other questions? Yeah.
I have a question on a different problem.
Okay.
Just like the one with the U.
Okay, we'll do that in a sec. But are there any more questions about this example? Okay, then what's the problem that you want to do?
Like question 3, it's like the U one.
Okay, we'll do this one too. Okay, so I want to find u so that, what? So that u negative 1/8 is on the unit circle. Okay, so let's get our QuickTime back. This is our goal. Find u. Find any numbers u such that the point whose x-coordinate is u and whose y-coordinate is negative 1/8 is on the unit circle. All right, well, I'm going to do a teacher trick here and send this question right back to the class. How might I determine a point whose x value is unknown, that's what I'm supposed to find, and whose y value is negative 1/8, subject to the constraint that the point must be on the unit circle? How should I start?
Plug it into x squared plus pi squared equals 1.
Yeah, we know that points which live on the unit circle, okay, points which live on the unit circle satisfy the equation of the unit circle. Namely, if this point has coordinates x, y, then these coordinates satisfy the equation x squared plus y squared is equal to 1, just like Sully said. So why does that help me to do this one? Yeah, I'm just gonna, this is supposed to be a point on the unit circle. If it is a point on the unit circle, then we can plug the x value in here, and we can plug the y value in here, and it should be equal to 1. So I'm gonna do that now. So what do we get? U squared plus negative 1/8 squared is equal to 1. Okay? So I'm supposed to find u such that it's on the unit circle. If this point is on the unit circle, then this equation is true, and I can find the values of u which cause this equation to be true. How exactly? Well, this is a quadratic equation. How do I solve quadratics? You just, you either factor, or in this case, you can just move everything to one side. So I'm going to rewrite this as u squared plus 1 over 64 equals 1. So subtract from both sides 1 over 64. I get u squared is equal to 63 over 64. And therefore, u should be equal to the square root of 63 over 64. So that is this point here. I found u so that this point is on the unit circle. Or is there anything else left to do? Well, let me ask this. Are there any other points on the unit circle whose height is -1/8? Yeah, there's one more. It's the one on the other side. That one also has height -1/8. Why did, I mean, I did the calculation. Why did I only get one number? I was supposed to have two of these. Well, I forgot to do what? Plus or minus. Anytime I do a square root, there's always going to be a negative number. Why is the negative number the square root? Because if you take that negative thing, okay, and you multiply it with the negative square root, then the negatives cancel each other, right? So we would still get the same result. So there's 2 points. And you can see clearly why that is true, because another way that you could rephrase this question is, where does the unit circle intersect the line y equals -1/8? So this is the line y equals -1/8. And it's a horizontal line. And of course, a horizontal line which passes through one point of the unit circle on the left side is going to also pass through a point on the right side, because it's got to go into the circle and then out of the circle. Okay, so how are you feeling about that one, Rando? Good?
I have a question.
Yeah.
For like should we simplify it?
Should you simplify it? You can if you want, yeah. I mean, technically there's a square root in the denominator here, so what we should do is, if we wanted to be following best practice, we would say plus or minus the square root of 63 over 8. That would be better. Does that answer your question? Yeah. Any other questions on this one? Okay, any other examples from the homework that you all think would be worth our time to check out? Okay, if not, then I'm going to use the last 10 minutes of class on what we were supposed to do today. No, I'm kidding. I really don't mind going through this stuff, because this is going to be really, really important to build a solid foundation. This 4.2 homework is probably the most important homework to have a grasp on for the rest of the class. So I want you to spend a good amount of time playing with that. So, okay, let me just tell you a couple of things and then we'll wrap up for today. So there are these things called trigonometric identities. So what is an identity? An identity is basically going to relate to quantities, all right? It's going to relate to quantities with an equal sign, okay? So an identity that we can use for trigonometric functions is that if I take an angle t and I plug it into the sine function, and by the way, what does this mean when I put a little 2 up here? That's weird notation. What this means is I'm going to take whatever is sine of t, I'm going to take that number and I'm going to square it, okay? And then I'm going to add to that whatever is cosine of t, I'm going to take that number and I'm going to square it. And I claim that if you take those two numbers and you square them and you add them together, then I get 1. Why should that be true? Yeah, because unit circle, right? What is the sine? The sine is the y value of a point on the unit circle. So this is like y squared, right? And what is cosine? It's the x value. So if I square it, I get x squared. And x squared plus y squared is equal to 1 because we're on the unit circle. Okay, that's because, you know what, why am I doing that? I need to just paste. There we go. So, why is this true? Well, if we have an angle T, why don't I, okay, just for fun, I'm going to draw the angle somewhere else this time. I'm going to draw it there, okay? That's fine, we can have an angle there. This point has coordinates, and the coordinates are whatever this angle is, okay? The x-coordinate will be cosine of that angle, and the y-coordinate will be sine of that angle, right? So if I take these two numbers, square them, and add them up, of course I'm going to get 1, because these are the lengths of the sides of this triangle. So if you square them and add them up, you will get the square of the length of the hypotenuse, which the length of the hypotenuse is 1, so 1 squared is just 1. So that's why we call them Pythagorean identities for trigonometry, because it comes from the fact that the Pythagorean theorem says what are the sides, how are the side lengths of a triangle going to be related. Okay, so there are 2 other Pythagorean identities, but I don't want you to ever feel like you need to memorize them, because all you need to do is know this one Pythagorean identity, and then you can always find out what the other ones are by dividing by either cosine squared or dividing by sine squared. So let's see what would happen if I took everything in this equation and divided by cosine squared. I would get sine squared of t divided by cosine squared of t plus cosine squared of t divided by cosine squared of t is equal to 1 divided by cosine squared of t. Sorry, was there a question? Are we good? Okay, so I'm going to divide these things. I'm going to make a little more space here. I'm erasing this. And what do I get? If I were to simplify this, what do I get when I take sine divided by cosine? Tangent, right? So if I do sine squared divided by cosine squared, what do you think I'm going to get? Tangent squared. And this one is just 1. And how about 1 over cosine squared? Yeah, that's secant squared. Okay, because remember, the world is not as it should be. Cosine, 1 over cosine is secant. 1 over sine is cosecant, okay? All right, so that's how we get one other Pythagorean identity. It relates the quantities tan squared with 1 and secant squared. So next up is, what do? I take this one and I divide by sine squared this time. If I do that, then I will get sine squared of t divided by sine squared of t plus cosine squared of t divided by sine squared of t is equal to 1 divided by sine squared of t. And if I simplify sine squared, that's 1, plus, what's this going to be? Cosine squared divided by sine squared? It's going to be cotangent squared. And that's equal to what? Cosecant squared. Okay, so these are the Pythagorean identities. We've got the first one here, second one here, and third one here. But I want to save room in your brain, okay? You need all the room in your brain that you can have, okay? Free. So don't memorize these two. All you need to do is memorize this one, the top one, and recall that, well, you can get the other ones by dividing by cosine squared or dividing by sine squared. Okay, so those are the Pythagorean identities. One comment that I want to add is, of course, that the angle must be the same for this to be true, okay? It's not true if we take sine of alpha, sine squared of alpha, which is one angle, and we add that to cosine squared of some different angle. Some different angle. This is not going to be equal to 1 in general. There are some specific cases, like if alpha is equal to beta, where it will be true. But in general, the angle inside must be the same in order for us to use the Pythagorean identities. Okay, that's because we're talking about a triangle in the unit circle, right? The triangle has to, if we're going to relate the side lengths of the triangle, we better be talking about the same triangle for both of the trig functions, okay? All right, any questions on the Pythagorean identities? Okay, then I think we'll close there for today. If you still need to get your quiz, come get your quiz.